This is going to be an exercise on the stress analysis package. This is what we're looking at, von Mises stress analysis. I have a load pushing straight down, and the end on the top where the red is flashing, this end has been clamped. So when we put pressure down on this plate, this end over here is taking on the majority of the load. This is where it's most likely going to fail. So you can run the stress analysis package. There's several different types of analysis you can look at, starting with the first one, the deformation. Again, I've clamped the top end so it can't move, and I'm putting all the pressure and load on this end, and just showing you per pounds of pressure, however many pounds of pressure I'm got. It's going to analyze the thickness of the plate, the type of material, and show you the range of motion you're going to have. The displacement, which is kind of the opposite of the von Mises stress, is this area over here is blue, and this one over here is showing the most red. This end is the end that has the most motion, and this end is the end that has the least motion. Versus the next one down, the von Mises, it's showing you where the greatest load is. And then you have factory safety one, the red indicating when it's at a dangerous point. And I don't know how to slow this down. I've tried, and my intuition is to try and go into this options and try and slow the settings down. But every time I hit it, it crashes. So I'm not really sure how to slow that motion down. This is the reaction force vectors. Okay, so when it goes, it's putting pressure down. One way it's where it's going to go up, it's showing pressure, and then where it's not going down as much, it shows a different color. So you got your different colors representing where there's more pressure and less pressure. And then the compression tension. So basically, if you're pushing pressure on this very end, the very closest part here is getting the least amount of stress on it. Over here is going to be the most, and as you work your way out like a fishing pole, kind of, you're getting more pressure on the part more towards where the clamping is. Rather out here, you're not really getting any kind of pressure on that plate. So for people wondering how to work the stress analysis package, where it's gone, what they've changed it to, I'm going to try and do this from scratch, and we'll see how that goes. What I do kind of like about the new package is it has all these check marks going down the list. It's kind of like the prismatic machine, the NC programming section, where it checks it off when you've got everything you need. And then we get to the results and we get to play the animation. So once everything's got the green check, you get to results, you get to hit play, and you'll get to see this. And in the analysis, you have information on each type of analysis that we ran. This could be downloaded onto a paper. So let's go ahead and try this from scratch. I'll just create a new part. And we'll make the part body the in-work object. We'll go into a sketch. And I'm going to sketch a really thin plate so I can have motion, make it crazy big. We'll start here, and I'll just type in the width. Type in a width of 20, and we'll just keep that a 1/10 of an inch thick height. I'll highlight this whole thing and auto constrain this. It's fully constrained profile. We'll exit out and build a pad. And I'm going to make it pretty long. I'll go 200 inches. Okay, so I got this big, long, skinny plate, and I'm going to go into, it used to be called finite element or stress analysis or something here. The one I ran was called static study. right away it's telling me I don't have any material. Now I can click on here and then hit material plates and then go add a material, go do a search and find the material. Or right in the middle of this, I could just go right back to the actual part itself. As you'll notice, the stress analysis creates a whole new working environment. So back in this part here, we can apply the material like we've learned in the previous classes by applying material down here in the tools options. And I'm going to search for 6061 aluminum, and I want to get the one that says core, and that's the one I want to apply. So we're not opening it, we're applying that. So you go ahead and hit apply, and then you have to close this window off. You'd think it'd know to close it off for us. I'm going to pick the top collector, which shows the material down here in the bottom. There's your 6061. That all looks good, so I can go ahead and hit the close command. That's the green check in the top of the middle of the screen. You can just click that and it'll apply that material. When I go back into the part, you'll see that the check mark green has been applied for material. I don't need this window anymore. Okay, so when you make your part, make sure you apply material. And then for a restraint, you have clamps, slides, hinges to work with. I'm going to do a clamp, and I'm going to clamp the surface all the way on the top. So right now I have nothing supporting. I'm going to zoom up. If I middle click right about here, it'll center that to the screen and also make that center of rotation. Makes it easier to rotate that part and zoom in close. Grab that face, and that whole face is what I'm clamping down. Okay, so that establishes an anchor, and if you go to the feature management pop-up window up here in the top pop-up window, feature manager, the middle one over here is the scenario where I've created a clamp. I'll zoom back out, and you'll see in the assistance window that I've got my second green check mark. You could apply more clamps if you wish, but I'm just going to do the one, and I'm going to apply my load now. And you have different types of loads. The load I'm going to apply here is pressure, and it comes in newtons by defaults. So I'm going to make a million newtons here, just really go crazy with this thing. Get a lot of pounds of pressure in there, and then pick the top surface. Oh, wait a minute. I'm going to remove that. Pressure. Whoops. And then support. So the more pressure you put, the more you'll get to see it bend. I'm just trying to put a lot of pressure on it just so you can see visually what's going on. I pick support and I pick the top surface, and that's where the pressure is going. I haven't really found a way. I know there's a way, I can't remember, but to put pressure just on that end. But I got pressure on my top surface, and I'll select OK. Again, it had the green check on there, so I've got the first three things checked. You'll see I've got clamp and pressure in my feature management window. Okay. Up in here, the scenario is that one end is clamped, and I'm putting pressure on the top surface. I don't need to add any more, so I'll go right to simulate. And what you do is, it's going to take a while depending on your computer, but you click the simulate start, and it's calculating everything for us. Back in the days, you had to do a whole bunch of math to try and figure this out. Well, that's what it's doing right now. It's doing all the calculations to apply however many pounds of load or newtons of load I put on the top, and when I clamp that in, how that's going to affect that part. So this could take several minutes. Oh, crap. I might have went too crazy on this. So what I'm going to do is I'm going to come back to my load, double click this pressure, and I'm going to change that. 1, 2, 3, whoa. 1, 2, 3, 4. So I got 10,000 newtons on here, and I'll hit OK. Now I can come back to simulate and let it calculate. And now I believe it's going to say your number is a little more realistic. I can handle this. If it goes too long, you might have to terminate that, but it will take several seconds. Son of a gun, why? I'm only doing one clamp. That's what I did last time, so I'm not really sure why it doesn't like the restraints I have. Let's delete the load, delete the clamp. I have 6061 material in there. Do my simulation. Material's good. I'll go back to restraint, select my clamp. I'm going to use a view command. Zoom area. Just do a little trap so I can get real close to that. Pick that face. ISO, fit all in. That's green, tells me I've got my restraint. I'll say okay. I'll go to my load, put pressure on the top surface. I'm going to put 10,000 newtons again, use the same one I did before. I said okay, I've got my clamp and my pressure in there. Simulate, click simulate here, and again it will take several seconds, and hopefully this time it will work. I used the same number, same parameter, same everything, so if it works now, I'm not really sure why it wasn't working the first time.